Well, thank you for the introduction, Simeon. And everybody, thanks for coming to my session about machine learning operations magic. We're mostly kind of focusing on the use of templates to make the step like from a notebook to production a little bit easier, especially for teams with data science that don't have like a large machine learning operations or DevOps department. And I've thrown in a tiny monorepo bonus, so let's get started. Well, some of you might be asking, why? Why such a focus? If you're one of the lucky ones, then I congratulate you. But for most of us, the step to production is pretty hard. You can also see this in some data. Over 87% of the machine learning projects actually fail, and 53% of prototypes actually reach production, so only 47% do reach production. And keep in mind, these are older numbers. I think in the age of generative intelligence, Gen AI, they're going to be a bit worse. So machine learning operation actually focuses on increasing these numbers and taking us to a better situation. Now, you might be wondering, what is machine learning operations exactly? Globally, it's a way of working that attempts to streamline your complete AI system lifecycle from A to Z. If done correctly, it should actually lead to a faster time to value, a reduced risk, and you can think of bugs, safety, security, performance, bias, all kinds of drift. And also, if done holistically, so there are also people elements, team management, team composition, archetypes, etc., it should lead to increased or better collaboration. Today, I'm just going to focus on the developer experience. And I really like the paper you see here, Operationalizing Machine Learning. If you have some time on Sunday, I would recommend you reading it. And it actually summarizes machine learning operations in 3 terms. Velocity is how fast can we actually reach value, or it gets really bright in here. Validation is how sure are we about this value. And versioning is how reproducible is this. Well, to go about this, I've designed something called a template. Well, this template is, so to say, project scaffolding. And it attempts to implement all kind of machine learning operation elements, so to make your life a little bit easier and to achieve this velocity, validation, and versioning. Pretty important for your template is that it should be able to roll out lifecycle updates. So your base template lives somewhere, and if you make some update or changes to it, then you want your projects that actually use this template or have already used it to also be able to receive any updates. So you need to be able to roll it out. It's important to remember that it's not a finished application, and this room is a little bit of a disco, so hopefully it's not too distracting. But what does it contain if it's not a finished application? Well, a template, in my opinion, should contain things related to project metadata. So things related to versioning, environment files, Git ignores, workspace settings to ensure all of your developer experience is the same. You might throw in there some Claude.markdown or agent.markdown files. You can already build your structure, implement tracking and monitoring things. So for experiment, model tracking, or model registry, data versioning. Also, you could include packaging and containerization elements. Also, you could include a bunch of quality elements like linting, formatting, type checking, security, secret checking, you name it. Finally, you could also include a testing framework. Well, obviously, testing is application dependent, but you could already build the ground floor that is required to make it a little bit easier. Again, make your life easier. Finally, we want to automate as much as possible and already set up some kind of CI/CD. So again, your life is easier. The fundamentals of a template, or actually in its basis, it's nothing more than like a repository, a Git repository that lives somewhere on GitHub or GitLab, and that actually uses a templating package. Well, in the Python ecosystem, we have 2 options. We have Copier and Cookie Cutter, but I would definitely recommend using Copier because Cookie Cutter doesn't allow for these lifecycle update management things. Now, I could tell you a little bit more about it, but I'm going to show you how it works, and this is always a bad idea. But let's get started. So, what does such a template look like? So here we have my Visual Studio Code. this is my base template. So this lives on our GitHub, and this contains all of the things I've added to it. And for now, it's important to just remember that there is a configuration inside it. Well, for copier, it's called copier.yaml. And within this copier.yaml, you have all kinds of things you will prompt the user with. So you will ask them, well, enter a fitting name, repository, package name, version, etc. These answers to these prompts will be used to populate the actual repository that is being generated. So you see it over here. In the first place, you already see a first field repository that will be populated by one of the prompted answers. But also you see a bunch of .jinja files. Well, Jinja is a templating engine being used by the templating package. So within all of these files, you will have, like here, fields that again will be populated by the answer the user gives. But let's just show you how it works. It's pretty easy. You only need one terminal statement and you need to use UV. If you don't know what I'm doing here, I will explain it in a little bit. But it's just as easy as UVX, copier, then say copy. Then you need to give the location where your template lives. So I'm going to say here, I'm going to say .git. Now I need to supply the location where it's going to end up. So let's say projects / demo. Right, if everything went correctly, we should be prompted with the first prompt inside this settings file, right? So let's give it a little bit of time, apparently. Oh, it jumped. Enter a fitting name. Okay, it works, thank God. AI, whoa, something was incorrectly, but let's call it AI demo. Okay, it automatically populated the repository field. Sure, sounds good. Package name, also great. Initial version number, again, sounds good. Let's fill in the name of the developer. Write a short description. Well, we're gonna keep it very short today. And finally, the Python version I want to use. Let's go with treatment 13. And it just did a lot of things. So let's actually open up the project folder that we just created. Oh yeah. Okay, luckily we have a backup. So, if I did my things correctly, it would have been what we see here. And now automatically we have a nice repository populated with all kinds of things. And we saw a bunch of .jinja files. Now all of this .jinja is removed. And we see that there is, well, some of the things you previously saw, there was a placeholder here, and now it's actually being populated, these fields. Okay, nice. Now you have a repository, there's all kinds of things in it, but how will this actually help me? Well, quickly recap. So a template should contain things related to project metadata, all these things mentioned here, versioning, environment, all kinds of extra files, tracking, monitoring, packaging, quality, testing frameworks, automation, and CI/CD. So let's start with the first thing that your template actually implements, and this uses UV. If you're unfamiliar with UV, I would definitely recommend you start using it. It's like a replacement for both Anaconda, Poetry, pip, PyEnv, lots of packages, and it's actually a versioning thing. It's dependency management, it's a Python manager, it's able to package your Python code, and it actually only requires one thing, well, officially two, but it creates this log file itself. It just requires a PyProject.toml. Within this PyProject.toml, you can see there's information, metadata related to your project. There is a script entry point. You can define all kinds of dependencies. You can define dependency groups. You can define tool settings. You could define your build engine, and this is just a global requirement for your eventual Python package. The log file is actually a very specified requirement file for your Python package. And what you can do with this is at the top here you see a virtual environment. But if we go to our demo, we don't see it. But we do see that there is already a PyProject Toml, right? So to make a new developer, to make them set, and to actually start developing, they only need to do the first string we just did, so the uvx copier copy, create a new project, and then run uv sync. And now it blazingly fast creates a environment, and my VS prompt prompts me, says yes. Very nice. If you're familiar with Conda, you know that this is fast and very nice. And it's done. So now we have a virtual environment based on our settings in PyProject and Toml, and our data scientists can just get started with development. So pretty nice. Recommend using UV. I've also mentioned a bunch of other things like environment files, git ignores, workspace settings, Claude, README, structure, etc. This is just, again, to make your life easy. So .environment.example, the example is there because else it would be removed by our git ignore settings. So already some git ignore settings. A workspace file, which can be used in your Visual Studio Code to make all settings within Visual Studio Code the same for all developers. So you could say if you want to format it on save or other related VS Code settings, and people can use them for all of their projects. Additionally, I like Claude, and I like including my Claude Markdown files already there, so people using the Claude web agent can already have their instructions ready. And the fundamentals of the README is also already generated based on the fact that this template will be used to generate a package in the end. Also, you could populate your repository with some folders that help the developer already have a better structure for their software. You don't need to use it, but it's there if you want to. Now, because data scientists like using notebooks and like developing there because you immediately get your output when you run a cell, we've also included like an experimentation or a notebook part of the template. So you could already start using it in your proof of concept. And to help them adhere to best practices, we've included like a example notebook that contains a better organization, so to say. Imports at the top, some options, some configs to make sure that people will actually use environment variables and not magic numbers within their code. And some tracking already set to use MLflow, because I would also definitely recommend some kind of experiment tracking, at least for your experiments. And if you start using MLflow, you can also use it later on for your monitoring setup, for your drift detection, for your performance degradation, all kinds of things. And MLflow also has data versioning, which is also pretty nice, and it's open source, I believe. So Jupyter I already mentioned. Also, finally, for our project metadata, we will include some things related to containerization. Because we know we're going to create a package, you can already populate your Docker file with like your UV image, copy your wheel, and just install it using UV, and you're good to go if you don't need any other dependencies. Again, this is also why UV is pretty nice. So, I've also mentioned quality. Creating a template allows you to build in all kinds of quality checks. And for this template, we've chosen to include all of these things you see here. At the top, we see rough. Rough is from the same people that created UV. It's able to do linting, formatting. It can just check, but it can also make changes. Pretty nice. We've also included Firefly. It's a type checking engine, static, and we've preferred it over something like MyPy because Firefly handles things like Pydantic models better. My current customer is pretty focused on security and safety, so a lot of security things have been added to this template. Bandit is a Python vulnerability checker. Trufflehawk is a secret scanner. And these two at the top here, this is HadoLint. It's a Docker file linter to check for bugs. And this is Aquatrivi that can scan your images. Finally, we have Dependabot that keeps your dependencies up to date for vulnerabilities. Well, all of these things can be run by using UV, UVrun, UVX, but this is still manually, and we will end up later to automate this and make your life as easy as possible. Also, I've talked about testing. Like I said, testing is very application dependent, so we can only lay the groundwork here. I like using PyTest and a tool called Coverage to tell you how much of your code is actually touched by your tests, but we can implement these kind of settings for the use of these tools already. Create a test folder. Again, in your workspace settings, you could include things like this. So yes, I want to use PyTest. And in your PyProject.toml, I've previously stated UV can use tools. So in your PyProject.toml, you can also define tool settings specific to those tools. Now, I've talked about making your life easier. And this goes hand in hand with automation. And the first kind of automation we implemented in this template is terminal automation. Terminal automation happens something called just. And at the top right, we see an example of a simple just file. Just allows you to, within the just file, create a bunch of commands where if you run just install, it will automatically run UV sync all groups for you. Or if you run just test, it will run UV run PyTest test. Well, in this simple file, it doesn't look that great, but as you can see in the template, it allows to go a lot more complex. So you can make automation just files for your Docker, for your documents, logging, packaging, quality, removing, setup, versioning, and it also allows you to define groups. So let's say if I, in this template, run the command just Docker, it will first build my package, then create the Docker image, build it, and you're good to go. So lots of things can be changed, you can change groups, and everything can be defined. Also, it allows you to make the life of the developer easy because running a simple just command tells you what all of your just automation settings actually do, and it explains you how you can go about this. Now, this terminal automation is still manual, right? So we want to make it a little bit more automatic. So these things we do with pre-commit hooks. Pre-commit hooks actually enforce your quality. Force the quality, that's why it's between these kind of things. But as we all know, you could also remove it or shut it off. But I just like to include it, and I hope my developers don't shut off my pre-commit hooks. The idea behind this is that you focus on commits. So you don't want to run your full test suite, you want to keep it fast, you want to keep it easy, and you want to focus on things that are important. So in our case, we run Bandit, we run I believe Commitison. Commitison is a tool that structures your commit messages, and it also helps you versioning your packages. We run Trufflehawk for secrets. We don't want large files uploaded, and it's just to keep your commits clean. Finally, we actually enforce our quality standards and all of our checks by including CI/CD. In our case, we're doing GitLab, and you see this GitLab configuration is currently in my repository. This will not enforce it because, again, somebody could just remove it. But if you make it in your top level settings of GitLab, you could enforce your complete quality pipeline. And what is also nice is, as you can see here, these just structure or the just commands you've previously configured and set up can also be reused within your GitLab CI/CD as just a group. So you can just run it and ensure your quality when you make actual push requests or merge requests. Is it perfect? No, it's not. If you're a big organization and you have lots of development, you might end up with lots of multiple repositories. You're not sure whether you have code duplicated. In the end, you have a lot of share packages that you reuse and need to maintain. And perhaps in the end, not in the template-related things itself, but in the package dependencies, some dependency conflicts occur, project teams using dependencies, everything ends up a bit shitty. But you need to be pretty big for this to occur. And last, by data, I saw a pretty nice alternative to this template way of working. And it's a monorepo, or actually the software architecture Polylit. And in its essence, a monorepo is nothing more than using, again, UV with a Python package, or at least the Python-based package of Polylit. And it allows you to create one large repository. Again, you can implement all of these quality elements I've just talked about, but instead of a template-based method, you create 4 different folders. You have a folder called basis, which contains all kind of codes related to entry points. You have a folder called components, so these are just populated with features, business logic, etc. Then we have a folder called projects. This is nothing more than a bunch of projects, or a bunch of folders with project names where a PyProject.toml lives. And within this PyProject.toml, you define what kind of components, or bricks, as Polylit likes to call them, you want to use for this specific project. So everything is in one repository. You won't get the dependency conflicts because you only need to maintain this very big repository. And you also have a developer playground where you could play around, create new bricks, do whatever you want. Though there are also disadvantages to this way of working, because if you have a very large monorepo, it gets difficult to know what kind of bricks and all kinds of things you already have in place. So it's not all. This is also not perfect, unfortunately. I would have loved to do a demo, but I think in the way of time I don't do it. But I will recommend you to watch. Oh, it was too fast. Oh, okay. Well, let's go. No. So, to just show you how easy it is to create like a let's to just show you how easy it is to create a monorepo, at least I hope I'm going to show you how easy it is, because I'm also not an expert at monorepos yet, but I will try. So we need to initialize this project using UV, and then I've added a little cheating thingy, because else I wouldn't remember it. So we add the Polylit. Okay, that's a shame. Oh, right. Yeah, the dependency groups needs to be def, but now I screwed it up even more. Yes. Okay, forget about it. Forget about the demo. I'm just gonna show you how an expert actually does it, and I will refer to Jeroen Bleker, his excellent talk at PyData. Very nice. He goes over his way of working. Apparently Netflix and a lot of large companies also use this monorepo way of working. We're currently still using our template way of working. Works very nice, but I saw it and I didn't want to keep you from you guys, because perhaps you work in a larger company, big DevOps groups, and this might be very excellent. Finally, I would like to close with something that Lech asked me. I would like to ask you to fill out his machine learning operations survey. He's doing research for machine learning operations related to... Fill me in, Lech, please.
Software sustainability.
Software sustainability.
Yeah.
Okay. It would help him a lot if you would take a small amount of your time to fill it out, and would be very nice. I've added it also here, and that was it. I would like to thank you very much for your attention, and if anybody has any questions, I would love to hear them.